What we discussed about IPv4? IPv4, it's a 30-day wait, 2 to the power of 32, 3.4.3 billion IP addresses. 4.3 billion IP addresses we are getting in IPv4. And IPv4, the total address is divided into 4 parts.
Sir,
Each part
screen is
is
not
8
visible.
bit.
Screen is not shared, sir.
Screen not shared. Oh. Yeah, now it is visible, guys.
Yeah, yes, sir.
I just I think so. What I done? I'm trying to edit the video, so obviously, okay. 32-bit video it is. So yeah, just okay. Morning we discussed about IPv4. It's 32-bit. So 2 to the power of 32 is a 4.3 billion IP address. Okay, so almost like a it's in a crores. You tell 1 billion is 100 crores. So it means 423 crores IP addresses you will get it. Okay. So for 29, so for 29 crores of IP addresses you will get it. So whatever it may be, total IP addresses is divided into 4 parts. Okay, so totally it's a 32-bit. So total it is divided into 4 parts. So each part is 8-bit. Each part is 8-bit. So because it's 8-bit, we call that one as an octet. Each octet size is 0 to 255. So your total range of IP address is 0.0.0 to 255.255.255. This is the total range of IP addresses. So first one we call it as the first octet, second is second octet, third is third octet, fourth one is fourth octet. Also some people will represent like this, certain materials and all. You can see also WXYZ just for easy to understand and easy to getting it. Okay, so you can use like this or you like this. It's not much differences, but like that. Okay, so each octet is either from 0 to 255 size only. Each octet is 0 to 255 size only. Not more than 255 is there. Okay, in a decimal format. So for example, if any octet having a more than 255 size, so it is invalid IP address. Invalid IP address. The total IP addresses are divided into 5 classes. Class A, Class B, Class C, Class D, Class E. 5 classes we are divided. And there is always a question why we divided a classes. Okay, A class, B class, C class. So that we will see. It depends upon size of the network. So we can choose a better option. So if you choose, if you don't divide the IP addresses, so we cannot manage the IP addresses easily. But when you divide IP address, you can easily manage the IP address based on the size of your network. And also we divide the IP addresses into private IP and public IP addresses also. Class of IP addresses we can identify by first octet only. So whenever you see the first octet, so based on that only we can identify which class it is. The class A range is 0 to 127. In a certain textbook it is 1 to 126 because of 0.0.0.0 is a reserved IP address for a certain services. 127.0.0.1 is reserved for a loopback address. And also we don't use any services. We don't assign to anyone like a 0 series. We don't use it. 127 series also we are not using it. And class B is 128.191. Class C is 192.223. Class D is 224.239. Class E is 242, 255. Okay, and in a class D is a multicast address. So usually we don't assign IP address of class D IP addresses. Okay, so that because it's a multicast, it is used by certain multicast related services only. Multicast related services only. Okay, examples are like a WDS services, WSTS services, okay, boot P services. Okay, like this, these are all multicast services. IIP version 2, IIS ERP, OSPF also use multicast routing protocols. Bad network quality. One second, guys, my internet connection slow. Some market is okay going on. 26, 27 is also okay. 30. Okay, good. Yeah, my network is okay, but still why it is showing that error? If you got error, that you will see. Guys, everybody can able to hear?
Yes, sir.
Yes, sir.
Yes, yes.
Yes, sir.
Multicast class D IP addresses we use for patent services only. Okay, so that's okay. Like a WDS services, boot P services, routing, dynamic routing protocols like a RIP version 2, EAS, ERP, OSPF use multicast address for exchanging routing tables. Okay, class E is we don't use the class E kind of stuff. And class A, class B, class C are a unicast IP addresses. We use class A, class B, class C only. Because class D is a multicast, class C is a R&D kind of stuff, so we don't use it. And we are using only class A, class B, class C only. So how to identify any class is based on the first octet. We have to identify the classes. Next, these are the private IP address ranges is given by IANA. If you use this any range, any IP address between this IP addresses, between this IP address range, if you use any IP address for your network, no problem, but it is in a private network only. You cannot communicate through internet. Okay. Anyway, private and public IP addresses, I will explain once we are gone through this subnet mask and all kind of stuff. So before we go to that point, so first of all, we should discuss about what is network in a, because IP address is a logical address. So what is this logical? What is network address? What is host address? How to understand network ID, broadcast ID, and how to calculate network ID using a default subnet mask like that. Now this is the networking IP address part 2. IP address part 2. Okay. Here it is again. Classes: class A, class B, class C. Only 3 classes. Why? Because of these are 3 are unicast IP addresses. As per the ranges 0 to 127, 128 to 191, 23. Next, guys, try to understand network and host concept is very simple. So, network and host. Very simple to understand is there is a building. Okay. here is a building or a hotel room, okay, or anything, just apartments. So you have a floors, right? So you have a first floor, second floor, third floor, fourth floor, fifth floor, like that. So a division will be there. For example, 101, 102, 103. For example, here it is 201, 202, 203. Maybe it is 301, 302, 303. Like this, anything. Just you can 304. You can put it 304. Okay. So here it is. So when you see 101, what is the meaning of this first one? What is the meaning of the second one? When you see there is a 102. What is the meaning of this one? What is the meaning of this one?
That's the first floor, room number 1.
Very good. This is represent first floor.
Floor.
This is represent second.
Second floor.
This represent first room, first apartment in the first floor. Second one in the first floor, first apartment. First one in the second floor. Second one in the second floor. It is like that, right? So we can easily understand by numbering it. So these two are belongs to first floor. These two are belongs to second floor. These two are belongs to third floor. These two are belongs to fourth floor. Or these are all belongs to fourth floor, like that. So we can able to divide into it. So one more example I want to tell. You know, guys, we are in a different places. So I will write some pin numbers. For example, my current location pin number is like this. Okay. Some people number is like this. For example, some are like this. Okay. So meaning is 5 means it's like Andhra Pradesh, Telangana, and some part of Karnataka, Visakhapatnam, Hyderabad, like this. So we can understand which state you are belongs to it, which area or which district area you are belongs to it. In that one, which town you are belongs to it. Okay, like this. How our PIN numbers, postal numbers are there. Postal numbers are there based on like we can easily identify which department, which area it is belongs to it. Okay, so logically, when you can able to divide them. Okay, what happened? It is disconnected or what? Bad network quality. What happened to my network quality? It is. It is okay, but why it is keep push messaging bad network quality kind of stuff? Network is okay. Okay, so here it is, guys. Here is the first rule. My rule. So the rule. Follow this rule so you can understand network kind of stuff. Okay. Okay. So network must be same. Okay. So you can write the rule like this. Is a network must be the same. Means network ID or network portion must be same. Okay. And host portion must different. So host portion is second one, but first condition is network portion must be same. So then two devices will communicate each other. Okay. So then the devices will communicate each other. So then okay. So within the network, this is within the LAN network. I'm talking about within the LAN network only, not so some other networks. Within the LAN network or a logical network. You both are in the same logical network. Also you can say like that. Okay. So network portion must be same. Host portion must be different. Okay. So then devices can communicate each other within the LAN or a network. So based on that rule, so we have to explain like N.H. N means network, H means host. N is 1, H is 1. This is one PC address. I have a PC1 or maybe PCA. Okay. So think like this. Network ID is 1, host ID is 1. Now I have a PCB. Network ID is 1, host ID is 2. Is the PCA, PCB can communicate each other or not? Yes. Because of both are
Yes,
in
sir.
a same network. Both are in a same network. Same goes for a PC3, PCC. Network is 1, host is 3. So these three PCs are in a same network only. So I'm going to another one. Here it is 2, 1. So the network IDs changes. It means these PCs cannot communicate it to PCD. These PCs cannot communicate it to these PCD.
Sir,
If you look at this host portion is
sir,
same, but network portion is different. Yeah.
what do you mean by host, sir?
Yeah, very good. Host means a device ID. Okay. Host ID means device ID. But currently look at the ID part only. Okay. Very good. What do you mean by host? That's a good one. Network and
Sir,
host.
it's a host
So it's a
device.
logical address, right? So the terminology, try to understand my terminology. Okay. So these are computers, their network ID and host IDs. So these two will communicate each other. These three will communicate each other, but these two cannot communicate it to this one. Cannot communicate it to this one. So that's just very simple to understand is. So network ID part must be same and host ID must be different. Okay. Next. If you want to make communication between two or more different logical networks, what we need? Different networks. You want to make a communication. What device you require? Need a router. We need a router to make a communication between different logical networks. Okay. So this is another point. This is another point. Okay. So first important rule is network portion must be same and host must be different in a same network, same logical network. Okay. So here we'll see, guys, as I said, host or a network. So everything is logical. Here it is. As we seen, this is 1, 101, 102, 103, 201, 202, 203. Logically, it is like a 1, 2. Represent. Okay, the first one or a first two, the first one is like here 1, 2, here 3 represent floor. It's a floor. It's just the first floor, second floor, third floor. But room number means actually the host kind of stuff, like a PC or a laptop ID. Actually, it is 101, 102, 103 means the 2, 3 represent room number in the floor. Same thing in our systems, it represent in a computer or a laptop or a mobile phone. But it is IP address. It is not room numbers, right? Our IP address is not like a 203, 204. It is look like a different one. Okay. So how our IP address are look like? So based on that, we have to write down that one. See, look at here. Class A, the first octet is network portion. Remaining is host portions only. Class B, first two are network portion. Next one is host portion only. First three are a network portion. The last one is host portion only. Okay. The first one is network portion and remaining is host portion. Here is the first two are network portion. Remaining is host portion. Class C, first three are a network portion. Last one is host portion. If you look at a class E, for example, here, look at here. So class A, first is one is class A type 100.20.10.2. Which class it is? Class A. First recognize which class it is. My PCA IP address is this one. PCB IP address is like this. PCA IP address, this is PCB IP address. Two systems are there. This is their IP address. Can you say PCA and PCB can communicate each other?
Yes, sir.
Yes, right?
Yes, sir.
How? Because both are
First,
class A and network portion is same. These are all host portions. Okay. You can see network portion is the only first octet. The first octet is same. That's it. Remaining is same or not. That's a different point. So PCA and PCB can communicate each other. Communicate each other. Next, same only. It will be laziness. Now tell me.
no, sir.
PCA and PCB can communicate each other or not?
Sir.
Check it. Network portion is same or not?
No, sir. No, sir. No.
No, sir.
Network portion is not same. Network portion is not same. Then devices cannot communicate each other. Communicate each other. So we'll go to another example. 151, 120, 150, 120. So 150 means class B. Class B means first two are network portion, next two are host portions. You have to compulsory verify first two. First portion 151, first portion 150 cannot communicate each other, right? Same example, same this one only. I'll put another example because 151 cannot communicate because first octets are same. Why this blurry sound is coming? Okay, still it is coming. Action failed. Okay. The noise is less. Okay, no noise. Okay, see here it is. The first octet is different, so that's why these two pieces are cannot communicate each other. Now first octet is same, but second octet is different, so we cannot able to communicate each other. Now these two pieces can communicate each other or not. First octet, second octet is same. Third octet, fourth octet is different. Can communicate each other or
Communicate,
not?
sir.
Yes, sir.
Can't, sir. No, sir.
Yes, right. Can communicate each other. Is it can communicate each other or not? This is really doubt. No, just for confusing you only.
Sir, class C.
Look at
Excuse
network portion is same or not. Can communicate or not?
Sir.
Yeah.
Sir, last example, post ID was not same for last example.
Host ID is
Before example,
this
sir.
one, right?
Next,
This
before
one, this
that
one.
one. Yes, sir. Host ID must be
Yeah, host
same.
can be different.
For class
Host,
B, host ID should be same, sir.
no. Here it is. Whatever it is, network must be same. Host portion can be different. Must or it they can. You can use can also. Host portion is different. Okay. So it can be different or a same, no problem. Okay. Host portion can be different or can be same. Okay. Can be same does not mean again column. I will tell you that one. For example, both are same, right? Both are same. Network is same, host portion is same. If both IP addresses are same IP address, both network and host portions are same, this is called a conflict. This is called conflict, invalid IP address. You should avoid this one. Okay, this is called a conflict. Avoid conflict. How to avoid a conflict? By changing host ID. Okay, host ID or ID or a number. Which one you put it? Okay, you guys are asked one question, that is, what is host ID or a host number? It's like these numbers are there. You really want a clear explanation, then we can also go with a clear explanation like this. See, you look at here. I have a computers. Think like that. I have devices or a computers are there. These are in a same network. Same network means physically same network and logically same network. Logically, they must be same network. Pieces want to communicate. Okay, so they're physically connected and logically also must have logical address. That is must be in a same logical number. Okay, for example, I have a plan.
Sir,
Yeah, tell me.
these all pieces has a same IP address, sir.
Same IP means not like this.
Uh,
If you have an IP address like this, it is called a conflict. Conflict is an error. You have to conflict. You have to avoid the conflict. This is same network. Meaning is
okay.
the
Only
network portion
is
must be same.
only network is same.
Yeah, network must be same. Okay, like yeah, one more is there, no? So okay, sorry, one more is there. Class C is there, so compulsory class C. I have to put it. So I have 194, for example. Yeah, that is enough. 194, 420 dot like this. Now tell me, can communicate each other? See, class
No,
C.
sir.
No, sir.
Okay, yeah.
No.
First
No,
two,
sir.
okay, same, but different here. Network is different in a second octet. Very good. Respect to what it is. Okay. Okay. Then now,
Yes, sir. Same.
okay. So network portion is same.
Yes.
Network portion is same. So they can communicate each other. Now,
No.
No, sir.
No, sir.
again, network portion is different. Network portion is different in this octet. Now, network
No.
portion is different.
Yeah.
No, sir.
Okay. So these are all won't communicate each other. This won't come. This will communicate each other, but this one, this configuration. So compulsory, if two pieces are not communicating each other, so compulsory check their IP address based on their classes. So compulsory verify their network portion is same or not. Okay. So what is this network portion and host portion? I will give you this one. When you take a network, so network is started with like this. For example, for easy to understand, I took a class C IP address. Okay, so 192. So no, I will take 194 is there now here. Dot 220 dot 10 dot 0. So this is the start of a network address. This is a network ID start of IP address in this network. And as I said, it's a class C. First three portions are constant. First three are constant, right? This is the first IP address. First valid host. First valid host or valid IP address. Also, we can say first valid IP address. Actually, we should not say valid IP address. We should say valid host IP address. Okay, we should not say this one. So valid host or valid host IP address. Meaning is we can assign this IP address to a PC. You cannot assign this IP address to device or a PC. Remember this one. So we cannot assign this IP address to device, or we can say PC or a system or anything you can use the word. Okay. So we cannot assign. This is we can assign. This is the first one. The one. Okay. Class C, guys. I'm telling you about Class C. Class C is different. Class B, the way it is little bit different. This is the second one. This is the third one. This is the fourth one. So like that, it keep goes. Okay. This is the last but one. Last but one type. This is last one. The last IP in the network, we call it as a broadcast ID. Broadcast ID. This is also we cannot assign to any device or a PC, whatever it is. Okay, this IP address you cannot able to assign it. So what is this last but one is last valid host IP address. It means we can assign to devices or PCs attached. So here also we can assign this IP address to any device. One second, guys. Sir. Okay. Okay, guys. So here it is. So I have opened mic or not? Yes. Okay. So look at this one. The first one is network ID. The last one is the broadcast ID. Okay. And here it is. We can assign IP address from 1, 2, 3, 4, and up to here only. This is the broadcast ID. It's the last one. So broadcast ID also we can't able to assign it. So what about the next level? So 194 is okay. 220, it become like this. So what happened here? It went to the next network. This is another network ID. So be careful when you are typing a IP address. So check it properly. The host portions, network portions, everything is correct or not. Okay. So see, this is the network from here to here, and this is the network. Okay, guys, understand? Network ID, broadcast ID, first IP address, last IP address. This is the range. This is valid range. This is the starting and this is ending. Okay, so here it is. Look at here. Same thing. I'm taking 194, 220, 10, 0. This is my network. This is my network. So which part is not changing? Which part is not changing? This part not changing. Okay, this part is not changing. And which one is changing? Last part. 1, 2, maybe 5. I will put a 10. Maybe I'll put a 20 here. I'll put a 30 here. So for all these species, the first 3 portions are not changing, but last portion is changing. But all are in a same logical network. So this we call it as a host ID. This we call it as a host ID, like a roll numbers. Roll number is there, na? Like a for example, I am creating a roll number here. This is 2022. 2022. So like a batch number 13. Okay, so like a 001. Next number is 002, 003, 004. Like this. I'll giving a roll numbers. The numbers are changing, which is identify each person. So for example, one for Sudhir, one for a Pawan, and with the names we are as liquid, and one for Lakshmi, Sai Kiran. So I given a roll numbers like this. Okay, I given a roll number for this one. So each person has a roll number, but what is the common? The batch number is same. Just like that. It is same as here also same thing. The network is same, but host ID is different. So each PC I will go and give the IP address like this: 194, 220, and 1. Okay, see, this PC IP address is 194, 220, 10, 10. So like this, each and every PC you can able to assign a IP address. But which one you cannot able to assign? 0 and the last IP address on the network you can't assign. Guys, understand this one? Host ID, network ID. Which one must be same? Which one is not required to same? Which is different? Which is not different? Okay. So then no one is telling anything, so no problem. So this is a one network. So I took this network. Which class it is? Which class? What happened?
Class S.
Class B, sir.
Class B IP address. So first 2 are network versions. The first one IP address is this one. That's the first IP address in the network. So that is a network ID. This is the first valid IP address. First IP address or a first valid host address. What is second one? Like this. Third one It's a series, right? 1, 2, 3, 4 numbers only. Just I'm putting in numbers. I'm not doing anything. I'm not thinking anything also. Simply I'm putting a sequence numbers only. I'm not doing anything. But if you look at the 0 is remains same, but 1, 2, 3, 4, 5, 6 is keep going. And finally, after certain typing, so I reach 16, 0, 254, 172, 16, 0, 255. So this is the last IP? No, because
One.
keep goes till my network ID must be changes. Keep on going on till the network ID changes. You know, when it will be changed, it become 255, 254, 172, 16, 255, 255, like this. This is the last one. After this one, definitely my network effect will be the 172, 17, 0.0. So this is the another network ID because network is changed. It is a different network from this one. So from here to here, it is a same network only. It is a same network only. So this is the last one. We call that one as a broadcast ID. I took a lot of time to explain this one. So if you understand, that is good. If you don't understand, that is bad. Okay. So this is the last valid IP address, valid host address. We can assign up to here. To PCs, we can assign any IP address from here to here. Meaning is this entire IP address range. So we can able to assign any IP address from this first to last to the host. So which one is constant? 172.16 is constant for entire network. So whenever the changes occur, then only it is a different network. So like this. So this is a same network only. They can communicate each other. Even though if you see the host IDs are same in the third octet, but here it is a different. Some difference is there, no? So like not some difference. It is like if you see both are in a first floor only. For example, if you take like this, both are in a first floor only. So we'll consider the digits. Okay. So how you see, look at the IP address is important. Okay. Class B. These two must be same. Any one of this host is different also. Okay. Both can be different, or both can be say one can be same, like that. So that's why I given a different variations also there, like a 1010, but it is different here. I said it is like this. See, it's a 1110. Both is like a some differences. Class B, mainly class B. See, look at here. Okay, sometimes it is same, sometimes it is different. So no need to worry about it. So important is whether it is same network or not. So we have to look at the network portion only. And what is the host portion? Simply it is like a numbering each device with a certain number along with your name. Okay, guys, understand network portion and host portion. I took a long time in class.
Yes, sir.
Completely gone in your mind also possible. Okay, that much you no need of take the class, but your understanding must be required. So The only thing is you have to take the different examples and try to understand it. Okay. The last point in this one is subnetting. In IP address, the last point is subnetting. Okay, I given already default subnet mask. Okay, I already told what is the default subnet mask. I given the information, but I didn't given what is this subnet mask and all. Guys, we know based on the network portion and host portion, we can understand which one is your network, which one is not in your network. Okay, which one is network, which one is not in your network, we can understand. But how computer can understand and how it can be manipulated? How can we manipulate and how computer is understand and how we can able to manipulate? So that is based on the your subnet mask only. Okay, this is how it will calculate, and default subnet mask also there. So where is this network portion, host portion? Yeah, here it is. So here only I'm writing 255.0.0.0. So how to remember? So where is the network portion? There it is, 255 is there. Where is a network portion? There is a okay. So where is a network portion? There is a 255 is there. Okay, remember like that. So we'll come back to that again. So class A, class B, 255 kind of stuff. So before going to that subnet mask writing, okay, I will write again here, but I want to explain how it is calculate. It calculates based on a NAND operation, NAND gate operation. Okay, so NAND gate is a logical gate or anything. Yeah, okay, guys, I will stop here. I'm going to stop here. Then I will explain the subnet mask. Okay, after break. After break, I will explain the subnet mask kind of stuff. Okay, in part 3 like this, we can make that one part 3. Then we'll see other kind of networking also today. Okay, so relax and stop the record first.